Is palladium key to cold fusion? Imagine a metal that can soak up a huge amount of hydrogen isotopes and might spark a tiny nuclear reaction at room temperature. Sounds like science fiction, right? Well, that's what makes palladium so fascinating in the world of cold fusion. Cold fusion is a controversial idea that claims nuclear fusion can happen at much lower temperatures than usual. The idea hinges on palladium's special ability to absorb deuterium, a heavy form of hydrogen. When palladium is used in experiments, scientists often run electrolysis with heavy water, which contains deuterium instead of regular hydrogen. The palladium electrode pulls in deuterium atoms, packing them densely inside its crystal lattice. Some researchers believe this could create the perfect environment for fusion to occur, releasing energy without the extreme heat needed in traditional nuclear reactions. The original experiments by Fleischmann and Pons in 1989 used palladium electrodes saturated with deuterium. They claimed to see excess heat that couldn't be explained by chemical reactions alone, suggesting fusion was happening inside the metal. But many scientists couldn't reproduce these results, and doubts grew. One big challenge is getting enough deuterium into the palladium without cracking it. When too much deuterium is loaded, the metal can develop cracks, letting the deuterium escape and stopping the process. Plus, if fusion is really happening, scientists expect to see nuclear byproducts like neutrons or tritium. Many attempts failed to detect these signals, casting further doubt. More recent studies have tried different methods, like applying small electrical voltages to increase deuterium loading without high-pressure gases. These experiments show some increased activity but no clear proof of energy gain. So, palladium's ability to absorb deuterium remains key to exploring low-energy nuclear reactions, but the exact process is still a mystery. In the world of weird science, palladium's strange properties make it a prime candidate for experiments that seem to challenge what we know about nuclear physics. The inconsistent results, the difficulty in reproducing findings, and the ongoing debate make palladium a symbol of scientific curiosity and controversy. To sum it up, palladium is indeed central to cold fusion research because of its unique capacity to hold deuterium. But despite decades of effort, cold fusion remains unproven and controversial. The role of palladium is still a puzzle, wrapped in experiments that are as quirky as they are intriguing.